everyone. My name is Terrance. I'm the co-founder and CTO of IOST. Okay, so IOST is a third-generation public blockchain. Right now, IOST has just finished all the functions of the mainnet, and the mainnet will be launched in the end of February. Okay, so we have been preparing for this moment for over 1 year and a half, and that's when we started this project. At first, is like me and some of my friends. We are all like software engineers, and we have been thinking really like doing something interesting, and we all have been knowing Bitcoin and Ethereum, and we just wrote a paper, and we thought, why not we just implement this? Okay, so today I will be introduce to you most of the functions we are offering and the features of IOST, and why we are special, and how we are building a secure and scalable blockchain for the general audience. Okay, so right now, we think a really big problem in the blockchain world is there's a really high level and high barrier to entry. Okay, so we want to bring the blockchain world, all the applications in the blockchain world, to have a compatible experience with the centralized services. Think about when you are trying to use a blockchain services or applications. Maybe you want to use a Ethereum application. What are you gonna do? You really have to spend a long time to understand what is really gas on Ethereum, and how do you pay for gas? How do you get your Ethereum tokens? So I've been doing a test, like when I was interviewing with someone who do not know blockchain at all. I will give them 24 hours to figure out how to buy a Ethereum and how to create an account on Ethereum and send transactions on Ethereum. You know what? All these smart people, okay, most of them, they will not be able to finish this task in 24 hours. So, yeah, you can really see the idea of how it's really hard for the entry barrier. Okay, so right now on EOS, it is even more. So Ethereum is just a gas-based blockchain, but on EOS, you have to figure out what is CPU, what is NAT, what is RAM, and how do you stake your tokens to buy each of this, and how do you trade with the system to get the RAM? Okay, so that's an even higher barrier to entry. And one of my friends who's in the blockchain world, he has to figure out, he's a software at Facebook, he's a software engineer at Facebook, and he's working on the blockchain project. He had to spend over 10 hours to create an account on EOS. Okay, so we really think in order to bring the blockchain to the mass, to the general public, we really have to create a really low barrier of entry for the people, and we have to really design a system that the blockchain world can have better access to other people. So that's the first problem we are thinking about, and we have been doing some special designs around that. Okay, all right. So one designing principles we have in our mind is we really have to keep the original property of blockchain uncompromised. Okay, so you all know the famous trilemma scalability. Scalability, security, and decentralization is really hard to achieve most three of these properties. And the thing is, when you are doing a blockchain project, you really have to find a balance. Okay, so Ethereum is more on the end of choose to be secure and choose to be decentralized, and EOS is more on the end of choose to be secure and choose to be scalable. Okay, so that's two ends on this spectrum. For us, okay, so finding a balance isn't easy, but what we want to do is we want to keep the central property of blockchain decentralization. What we mean that is we have to keep the censorship resistance property of blockchain, and we see that's the utmost important property of blockchain. The systems like EOS or similar DPoS system, someone says maybe it's like an inferior database. It already has begun to censorship transactions, so that's something we really think is compromised the core values of blockchain. And when we are designing this blockchain system, we don't want to do that, and we want to keep the decentralization part as a key. Okay. So first, how we are redesigning this world entry to the blockchain world. So we have to think about what are the resources in the blockchain world. If you are trying to use a centralized system, if you are trying to use AWS or Microsoft Azure, what you are paying for you to use those systems? Okay, you have to pay for the bandwidth fee, you have to pay for the storage fee, you also have to pay for the different types of computer, right? So the computer, if the computer has a higher processing power, then it would cost more. Okay, that's the similar case on blockchain. So that's why in EOS and on Ethereum, both of these blockchains, they has an economic model. On Ethereum, this central thing is called gas. Okay, whenever you have to use some resources, you have to pay for gas. If you want to store something on Ethereum, you have to pay for gas. If you want to send a transaction, send some data through the network, you have to pay for gas. If you want to use the computing power, you also have to pay for gas. On EOS, it's sort of different. On EOS, all the resources has been divided into three parts. You have to trade with the system to get the RAM resource, and you have to stake your token, stake your EOS to get more CPU and to get more net. However, it's really hard for you to figure out what essentially are this and how do you distribute the tokens in order to get enough resources. Right now, if you create an account, how do you know how much CPU I should get? How many milliseconds my applications will able to use? I have no idea to figure that out. So that's one of the problems we have to address. All right. So the first thing about this abstraction is we have to use a very efficient abstraction model of all the computing resources we have in all the blockchain networks. Okay, so as I mentioned, one is gas, one is the three combined resource, and for us, we have researched on this a lot, and we have several findings. So first, we really have to make the efficient usage of all these resources. So sometimes on Ethereum, you'll see a huge surge on the gas. That might be when the FOMO game is coming out, when the CryptoKitty game is coming out, and the gas price has surged. But that gas price surge will affect your usage of all the essential resources. Suppose everyone is using the CPU and the gas price is surging, but you have no way to use the network resource or the RAM resources for its current price because everyone is using the CPU and the gas is all tied together. So that's the problem we see. There's really low efficient usage of the resources. So for us, we have found out for all the applications, actually, there are two types. One is either storage intensive or it's either CPU intensive. We have almost never seen such an application that's network intensive. So we have combined more of the computing power and the network, the computing resource and the network resource to combine as the IGAS, and we tied this with a very new mechanism. That is, our resource has no fluctuation. I'll mention that later. Okay. And another thing about RAM is you probably all know this is the infamous RAM price surge. At some point in EOS, the RAM price has surged a lot, and people can get a lot of RAM, and we hoard the RAM, and we can bump the price of the RAM, and then we can sell those RAM to other people. So this is really a bad way for people to use the system because we shouldn't have this system to be able to abused by the users in order to make more money. All right. So that's why we chose another ingredient-based algorithm for the system trading with the RAM instead of the Bancor algorithm used by the EOS system. Okay. And okay, I'll show this graph first. So this is made by one of the EOS supernodes, and it actually shows the resource fluctuation rate for the CPU, for simply the CPU. You can see the CPU price. That means if you stake one EOS, sometimes you can get, this is on November 11th, 2018, you'll be get 0.1 milliseconds to use the CPU. But sometimes what you'll get is maybe 120 milliseconds to use the CPU time. Okay, your experience is really unstable. It's really unpredictable. And what's worse is when you are playing a game, sometimes what games have you ever played on EOS? We are playing a gambling game or simple game. You have to stake some CPUs. You have to stake your tokens to get some CPUs, right? And sometimes when other people came in, when new people join the network, and suddenly what happened? Your CPU get diluted, right? Your CPU gets fluctuated. Isn't that a really bad experience? The amount of resource you are getting is affected by others, by others who is joining and leaving the network. So that's really put an unstable experience for most of the users. And that's I found really unusable for the current network. When I first play the game, I first have to maybe stake 100 EOS. And after that, sometimes your CPU will just, even if you don't play any game, you are not using any CPU, and then your CPU consumption rate will be going to 100% because other people join the network. So observing all this problem, so we want to change the fundamental design of how the network resource in the blockchain system is distributed to different users, and we want to give a more stable and a more predictable experience for the users. Okay. So essentially, how we're designing this is we are combining the staking model with this transaction scheduling model with two. Okay, so we are taking the advantages of both of the blockchain world to combine. Okay, so what I mean by that is first, you all know on Ethereum you have to pay for a transaction fee. That's a one-time fee, and every time you are using the network, you have to pay for that fee. And this sort of makes the network not microtransaction friendly, and it will be more of the latencies for the end users. Okay, so first we have to take this out. We want to make people have zero knowledge and have zero feeling of this transaction fee. Okay. Maybe we have to design something to have user pay for them, but we want to make this hidden from the user. We want to hide all these tiny details from end users. So we have to design a highest fee first model without the transaction fee. Whenever people is staking the IOST token, we will first generate a fixed amount of IGAS for them. And this amount of IGAS is regenerating every day. And after that, we can choose to pay whatever IGAS to schedule your transaction. Whenever the network is not jammed, you can pay for the lowest fee to get everything sent. But whenever the transaction is jammed, whenever your system is jammed, think about the current system. In EOS, what will happen? Your transaction will be dropped, right? Okay, so if there are more transactions than the current throughput, and then that transaction has to be dropped. And that's why right now, a lot of the blockchain games on EOS, they are experiencing this transaction drop because you have no way to prioritize your transaction. There's no way for you to know your transaction will be guaranteed to be processed. And there's a way actually in Bitcoin and Ethereum for this to happen is for you to pay a higher fee. Because we're having this highest fee scheduling first model, block producers will be able to pick the highest fee transaction, and there's a way for you to prioritize your transaction when there's a congestion in the network. Okay. So first, we are giving all the users, when they are staking the tokens, you get a free amount of IGAS every day. And after that, you can stake this free token to prioritize your transaction. So by combining this way, first, we give you a fixed generation of the resource you are consuming every day. This is not affected, this will be not diluted, it's not fluctuated by different users coming to the network, and it doesn't affect by the previous users or later users who are using the computation resources. And also, you have a way to prioritize your transaction when the network is jammed. Okay, so that's sort of just to quick recap is we have redesigned really a resource and account model for the users to enter this blockchain world. We want to have a very efficient resource abstraction for the current system and give people a lower barrier to enter. Okay, so we want people to have a more stable and more predictable experience without worrying too much about the underlying technical details. And one of our goal in the current year, actually right now, is we want to bring more users to use the blockchain, and that's we see so that's why we have a lot of creative we have a lot of creative designs on how the account system should work. Okay. And another thing we are observing in the blockchain world is so the blockchain technology essentially lies in the consensus algorithm. You have to make your consensus scalable. You have to make your consensus secure, and the consensus is actually determining the core of your blockchain. So sometimes the hardest part is also lies in this. So what we are trying to achieve is, first, as I said, our designing principle of the blockchain is we have to keep the decentralization priority always. We cannot achieve better transaction throughput at the sacrifice of the decentralization priority. So always we have to keep the censorship resistance as the first place whenever we're trying to exploring more scalable things. So how many nodes do we have in the system is one important indicator of how decentralized your network is. You guys probably all know how many nodes are there in Bitcoin or how many nodes are there in Ethereum. It's roughly about around the number of 10 to 20,000 nodes around the world. And how many nodes are there in, say, EOS or in Tron or in some other DPoS-based system or in some other pretty centralized system? Okay, 21, 27, 36, just, some number around that. So it's really a two different level of decentralization. And so that small amount of node have a lot of problem for the centralization to happen. As I mentioned first, there's already the problem of transaction censorship, and also there's right now this is actually a bigger problem is all these nodes can be formed like a mafia. So all these nodes right now, they are very fixed, and there's no way for them to be switched out because they are bribing around each other for these votes. Right now, in all the DPoS system, all these mafias have been formed, not only in EOS, not only in Lisk, and lots of this system. Okay, so we don't want this to happen. We want to give equal opportunity to all the nodes. We want to give all the nodes to have an equal chance to produce the block and to get the corresponding block production rewards. Okay, at the meantime, we want to have the nodes first being distributed and then cannot be centralized at one place with a certain number. So we have designed our consensus. So we call that proof of believability consensus, or in short, POB. I think it's a bad word. It's really hard to pronounce. So I usually say in a short format. So POB consensus essentially is, first, not like proof of work, you have to select the nodes who actually have the largest processing power in order to get the production rewards. Not as in POS, where you probably have the largest amount of token state in order to win the chance of block creation. In POB, we're actually using your amount of contribution you made in the network, and that factors in first the token in stake and also the transaction you have been verified, the transactions you have been sent, and the network topology you have in the underlying network topology. Okay, so if you are more in the hub of the network, you'll be getting more rewards. And if you are not in the hub, more in the rural area, you will probably not get as high reward as in the hub of the whole network, because you are essentially verifying more transactions and relating more transactions. Okay, and moreover, besides that, so your contribution score is actually calculated by this survey. So survey is actually the score you got for a contribution level. And besides this, the survey mechanism for you to be selected into the committee, we also have a frequent rotation. So right now the rotation is set to be 10 minutes. So we have a small group of nodes who is running the committee, and they are producing the block, they're getting the block rewards. And after 10 minutes, their survey number will be cleared. So that's a unique design in our system. after the survey number is cleared, so you will be getting less and less survey scores by most of other nodes. And after that, what will happen? The nodes with the less number of survey will be selected. So by taking out the survey score of the highest several nodes, we are trying to keep the rotation going on. Okay, we always clear the nodes who has the highest survey after they got the rewards, and after that, the second batch, the third batch is going to rotate in this committee, and after that, more and more nodes, essentially all the nodes will be in the production phase. So by doing this, right now we're actually in the application of the nodes, and everyone can apply to be a node, and also nodes is rotating every 10 minutes to produce the blocks in order to get the production, in order to first facilitate the network and then to promote the network. Okay. So right now we are setting a really, really low barrier for the entry in order for you to be a node. So essentially there will be thousands of nodes, and by doing that, we are trying to achieve the same decentralization level as some of the most secure blockchains in the world, such as Bitcoin. Okay, so that's actually a high-level overview of the consensus, and we actually have a more detailed design in our white paper. If you are interested, I can maybe spend another session on that, but that's a high-level overview. So we are calculating the survey, the contribution you have made in the network in order for you to be selected into the block creation row. And also we are frequent rotating this committee for the block producers. Okay. Okay, so some other thing we have made is we have designed a pretty flexible smart contract system. So right now we are supporting JavaScript and a native Golang for smart contract, and we have used a Linux file system style control on the smart contract. So smart contract control is actually another problem in the current blockchain world. If you have ever been as a DApp gamer or creator or companies, you will find it's really hard for you to manage your smart contract. Okay, so it's hard for you to hard for you to upgrade, and then hard for you to delete, and it's further hard for you to maybe transfer the control and getting more control-based management on the smart contract. Okay, so we essentially adopt the Unix file system control on the smart contract. That means you can first, different body have different access control on different smart contract, and certain people can have a certain access and control on smart contract. That means someone will be able to delete the contract, someone will be able to upgrade the contract. If you want to maintain a contract and you have to upgrade the contract, you really don't need to deploy it again. You really don't need to pay for that highest fee again. You want to have your contract deployed. You can just have a compatible experience with a centralized services upgrade. So we're really trying to make these two worlds more similar, and in order to give a better developer access to the smart contract. And after that, if you are coming probably with a traditional developer background, you'll know like maybe you have used system like Spark or Kafka. So we have made a similar feature as that. So we have recorded all the blockchain live events on blockchain and off the blockchain. So think about the life cycle event of a transaction, of a block, of a node. So of this, we have produced a data stream for you to use. Some essential part is on the blockchain, and some other part is off the blockchain. So you can really use a Kafka style processing to subscribe yourself to different topics. Okay, and then you can catch the signals and the events you want to catch in all these life cycles of the blockchain. So this will really facilitate your implementation and development work for your project. So that's something we have also adopted from the traditional large data and data processing framework to better facilitate the current blockchain world. Okay, all right. So we have the event topic subscription similar to Spark and Kafka. Okay, and furthermore, we are really seeing the current virtual machine is really problematic, and we have actually redesigned a virtual machine based on Chrome V8. And the reason to choose Chrome V8 is we have done a lot of testing, and after that we have found this is the most efficient way to have a transpilation engine while giving the sandbox security property. Okay, so I'll not go over into too much details, but this is a two-layered cache storage part, and this is a unified response and request module. Well, we also can spawn different VM workers. They'll be actually sharing a lot of the, okay, so this will be optimized by the snapshot function, and these are actually providing first the sandbox and then the hotspots, the snapshot hot load in order to reduce the memory footprint. Okay, and if we zoom in better into the storage, we have take advantage of the MVCCDB. Okay, so MVCCDB is something we really use in order to give all the data access in the blockchain a better, a lower latency and higher throughput. Okay, so whenever a fork comes in the traditional block world, how people handle that is you have to roll back. Okay, there's no way for you to quickly get the old data. So by observing this, we have been taking this MVCCDB multi-level concurrency control database in order to concurrently store all the different versions of piece of data. And whenever a fork is coming, you can efficiently grab that piece of data without rolling back the transaction and without a fork mechanism. Okay, so this in the current test is really facilitating well with the data access whenever a fork comes in. And that's one of our unique design to make the developer experience more compatible with the concurrent centralized services. Okay, so by using this MVCCDB, we actually can have maybe tens or thousand milliseconds access in order to get a persistence layer of data, and that's really a huge performance boost. Okay, so and also we have based on different SLA, we have a different switch for either LevelDB or RocksDB or whatever key value DB you are going to plug in. So this is made pretty modular, and your our state DB can be changing really simply. And also the cache. Okay, so the cache is actually two-layered. We have a generic cache, and as I said, we also have an MVCC cache. So the generic, by using a generic cache and MVCC cache, we can not only provide data fast data access whenever a fork comes in, but also we don't have to default into the persistence layer most of the time. So most of the queries will hit the cache. Okay, you don't have to hit the persistence layer. Okay, and another part where we are really trying to optimize is the decentralized network layer, where we have been tested a lot of the compression algorithm in order to have the data be more being more compressed and sent more efficiently over the network. Okay, so by using first the snappy algorithm and then we're using the protobuf, we can effectively achieve 80% data compression rate for all the bytecode sending over the network, and that's really a huge performance boost. So by doing that, that actually has gave a huge boost on the virtual machine performance, and developers really don't need to worry your transaction is having a too large amount of data being sent in the network, and then probably your transaction will be dropped, or you have to pay a too high fee in order to get that transaction processed. Okay, so we have been optimized at that end on the network layer. Okay, and accessibility is actually according to the LAN penetration where we made, and the discovery is the data routing, where we're actually also using a creative way to do both of this. Okay, so the LAN penetration. All right, So I've covered some unique part of the IOST system. So just a quick summary. Essentially, we are just trying to make the developer experience and user experience more friendly. We want to lower the entry for the people to come into this blockchain world, and we want to give them a compatible experience with the centralized services. So in order to achieve only achieving this, we believe people can have a more willing in order to migrate from their right now currently using an awesome centralized applications. And we are really on this way, so we are constantly trying to improve more. So if you have a better idea, maybe in the storage layer, network layer, account system, we really welcome you to join our community. So first, we have a developer community where right now it's pretty active. We have a lot of developers discussing the application development work, and it's looking for maybe collaborations. So there are a lot of the blockchain technology discussions in our Slack, and if you trying to maybe develop the app, you can also maybe find your partners there. So it's really helpful and collaborative. And yeah, so if you are a developer, you're also welcome to visit our developing resource site. We have like guides of how to run the app, how to write your own app, how you can run a node, and all the technical details explanations is on our developer site. Okay. So at the end of February, our mainnet is launching. It's just it's in about a month. And right now, our testnet has already finished all the functions of our mainnet. And we are really welcoming all developers to come join our testnet and maybe play around with it, give it a shot on building something creative. And I think together we can bring more users into the blockchain world. And we are always on this effort to make the blockchain more accessible to the general audience. Okay, thank you.